Part 1: Prototyping and Lighting Logic. We've officially wrapped up our second prototyping pass. Until now, we've focused strictly on the bones of the level, getting the floors, walls, and basic architecture in place. Since the last session, I've made a few off-camera adjustments to clean things up. I added some columns to the initial room to break up that empty, boxy feel and gave the ceiling a bit more depth by recessing a section. More importantly, I started swapping out our standard point lights for rect lights. Before we dive into today's main task, let's look at why that change matters. Previously, we used point lights, which function like a bare bulb, casting light in every direction from a single center point. While those worked as temporary work lights so we could actually see the space, they aren't ideal for a finished interior. If you check the Place Actors panel, you'll see several other options beyond the standard point light. One of the most useful is the rect light. Unlike a point light, this emits a steady glow in a specific direction from a flat plane. The best part? With the light selected, you can jump into the Details panel and scale its dimensions to perfectly fit your environment. For interior scenes, rect lights are a game changer. They are perfect for ceiling fixtures. You can rotate them to face downward and adjust the width and height to match the size of your light source. This mimics the even, uniform glow of fluorescent lighting much better than a single point. It allows one light to cover a larger area while giving you extra control over the beam angle. I'm keeping the lighting simple for now since we're still prototyping, but I wanted to clarify these changes so you aren't lost. Most of what you see is just a refinement of the techniques we've already covered, moving walls, adding columns, and adjusting shapes to make the first room look more intentional. Now, let's shift gears into scripting. In Unreal Engine, we add logic to our games using a visual, artist-friendly method rather than writing traditional lines of code. This is known as the Blueprint Scripting system. You've actually seen this briefly when we tweaked the default player character. If you head back into the third-person Blueprints folder and open the character file, this layout should look familiar. Think of a blueprint as a container. It holds various assets that, when combined, create a functional object. In the editor, these individual parts are called components. You can see them listed in the Components window, things like the character mesh you see on screen, the camera that follows the player, and various invisible logic elements that run behind the scenes. Beyond just being a container for parts, blueprints house the event graph. This is where the actual logic lives. Under the hood, Unreal Engine runs on C++, a complex and highly technical language. To make development more accessible, the creators at Epic Games developed this visual system. Essentially, blueprints act as a user-friendly layer over that C++ code. Instead of typing out lines of text, you'll be connecting visual nodes to build your game mechanics. We've already touched on this briefly with the character settings, but now we're going to use it to build entirely new gameplay elements from scratch. Every obstacle we've planned for this level will rely on blueprint scripting to function. To see why we need this, let's look at our current build. In the second room, we have several bottomless pits. If you fall into one right now, you just hit the floor and get stuck. There's no game over and no way to restart. In game design terms, that's a game-breaking bug. To fix this and speed up our testing, I'm going to adjust our spawn point. While you can always right-click in the viewport and select play from here, I find it faster to just move the player start actor. I'll delete the one in room 1, head over to the Place Actors menu, and drop a fresh player start right into room 2 so we can test the pit logic immediately. Now, when we hit play, we start exactly where we need to be. Moving the spawn point saves a massive amount of time. There's no need to run through finished sections of the level just to test a new trap in a later room. Our first order of business is fixing these pitfalls. We need a way to tell the game, if the player falls to this specific depth, they should die and restart. Fortunately, we don't need to write complex code to track height coordinates. Unreal provides a built-in tool for exactly this purpose called the Kill Z volume. Go to your Place Actors window and search for Kill Z. When you drag the Kill Z volume into your scene, it appears as a wireframe box. This box is invisible during gameplay, but it acts as a trigger. As soon as the player's character touches any part of this volume, the game will automatically trigger a kill event. To set this up, placement, drop the volume into your pit. You want the top of the box to sit at the exact height where you want the player to die. Scaling, use the scale tool to stretch the box so it covers the entire width and length of the hole. We want to make it error-proof, ensuring that no matter where the player falls, they can't bypass the trigger. Orthographic views. If you're having trouble lining things up, switch to the top or side orthographic views and set your display to wireframe. This makes it much easier to see the yellow bounds of the volume relative to your level geometry. The goal is to position the volume so the player hits it well before they reach the actual floor of the pit. This maintains the illusion of a bottomless drop while keeping our gameplay loop functional. If we test the level now, you'll notice a problem. When we fall into the pit and hit the kill Z volume, the character simply vanishes. The camera freezes and the controls stop responding because there is no longer a player to command. Since we haven't told the game what to do after a death, we're stuck in a void until we hit escape to return to the editor. To fix this, we need to establish a set of rules for the level itself. This is handled by a specialized file called the level blueprint. Understanding the level blueprint. Every level you create in Unreal, like the one we built from the New Level menu, is essentially a file in your content browser. Every one of these files has a dedicated blueprint attached to it automatically. This is where you write logic that applies to the entire map rather than a specific character or object. To open it, look at the top toolbar for the blueprints icon. Select Open Level Blueprint from the drop-down menu. I recommend docking this tab next to your viewport so you can switch back and forth easily. Navigating the editor. The layout is nearly identical to the character blueprint we used earlier. You have the event graph in the center and the details panel on the right. The main difference is the absence of a components tab. That's because the components of a level are simply the actors and objects you've already placed directly into your scene. Working with nodes. When you first open the graph, you'll see default events like Event Begin Play. If they look grayed out, it's just because they aren't currently connected to any logic. In Unreal, these boxes are called nodes. To build a script, dragging pins, click and drag from the white arrow the execution pin on a node. The action menu, releasing the drag, opens a search menu filled with every possible action you can trigger. Context sensitivity. This menu is context sensitive by default, meaning it only shows actions that actually make sense for the node you are pulling from. This helps prevent errors by filtering out incompatible commands. Our next step will be using this graph to tell Unreal, the moment the player is destroyed by that kill Z volume, restart the level. When searching for nodes, keep the context-sensitive box checked. It filters the massive library of Unreal commands down to only what works with your current selection, preventing broken code. If you ever accidentally delete a default node like Event Begin Play, don't panic. Just right-click, search for it by name, and you can place it right back into the graph. Creating a player reference. Our first task in the level blueprint is to tell the level exactly who the player is. We do this by creating a reference. Think of this as creating a shortcut or a saved contact so the level can quickly send instructions to the player character later on. Get player character, right-click in the graph and search for Get Player Character. This node is a pre-written function from Epic that identifies who is holding the controller. Player index 0, you'll notice the player index is set to 0. In programming, counting almost always starts at 0 instead of 1. For a single-player game, index 0 represents player 1. The return value, the blue pin labeled return value, holds the identity of the player. However, Unreal needs to know specifically what kind of character that is to access its unique features. Casting to your character. To bridge that gap, we use a process called casting. Drag a line off the blue return value pin and search for Cast to BP third-person character. What is casting? It's like saying to the game, I know this is a generic player character, but I want you to treat them specifically as my third-person character blueprint. Why do it? This allows the level to talk to the specific movement settings, animations, and variables we've set up for our hero. By connecting Event Begin Play to this cast node, the very first thing the level does when it starts is identify the player and confirm they are the correct character type. This sets the stage for our respawn logic. Computers don't assume, they only follow direct orders. Even though we know our player is the only one in the world, we have to explicitly verify that the character spawning in is the correct blueprint before the game can interact with it. Storing information with variables. To make our life easier, we want to store the result of that cast so we don't have to keep repeating the check. We do this using a variable. In game dev, a variable is just a container for information, in this case, the identity of our player. Instead of manually creating a variable and searching through a massive list of types, there's a shortcut. Right-click the As BP third-person character output pin on your cast node. Select Promote to Variable. Name it something clear like playeref. Now, whenever we need to do something to the player later in our script, we can just grab this playeref instead of starting from scratch. Referencing actors in the level. The level blueprint has a unique superpower. It can see objects that are already placed in the scene. Unlike the player who doesn't exist until the game starts, our kill Z volume is already sitting in the pit. Go back to your level editor and select the kill Z volume. You can find it in the outliner if it's hard to click. With the volume selected, return to the level blueprint and right-click in an empty space. Because of context sensitivity, the menu will show options specifically for that volume. Adding a collision event. We need to trigger an action the moment the player touches that volume. Navigate to Add Event Collision, Add on Actor Begin Overlap. This creates a red node. Red nodes are events, they are the starting line for a script. This specific event says, the moment anything enters the physical space of the kill Z volume, run the code connected to this pin. We want to make sure that anything is specifically our player, and then we'll tell the game to simply restart the level. Right now, our kill Z volume is triggered by anything that touches it, including the floor and the surrounding walls. If we added a restart command now, the game would loop infinitely the second it started. We need to filter the trigger so it only responds to one specific thing, the player. Using your player reference. Remember that playeref variable we created earlier. Now we're going to use it. Go to the Variables sidebar. Click and drag playeref into the graph. Select Get Playeref. This provides a node that represents your player character. The equality check. To ensure the object touching the pit is actually the player, we use an equal node. Drag a line from the other actor pin on your overlap node. Type double equals in the search. In programming, equals is used to check if two things are identical. Plug your playeref into the second slot of the equal node. Branch is the if statement. Now that we're checking for a match, we need a way to say, if this is true, do X in Unreal. This is called a branch. Shortcut, hold the B key and click anywhere in the graph to drop a branch node. Connect the red Boolean pin from your equal node into the condition pin of the branch. Connect the white execution pin from the overlap event to the input of the branch. Staying organized with comments. As your script grows, it can become a spaghetti mess. To keep things clean, use comments. Click and drag to highlight a group of related nodes. Press C on your keyboard. Type a label like Identify Player on Start or Pit Death Logic. Now you can move the entire block of code as one unit, keeping your workspace professional and easy to read. Visual Guide to Colors. Unreal uses color coding to help you read logic at a glance. White execution flow, the pathway of the code. Red Booleans, true-false logic. Blue actor or object references. Teal integers, whole numbers. We've now built the brain of the trap. It successfully identifies the player and ignores everything else. Next, we'll add the actual instruction to restart the level. Before building a complex function, you should always test the logic incrementally. If you wait until the end to test a massive script, it becomes much harder to pinpoint exactly where a mistake occurred. The best tool for this is the print string. What is a print string? A print string is a node that displays a message in the top left corner of your screen during gameplay. It's the hello world of game development and a staple for debugging. If you aren't sure if a specific part of your code is even running, connect a print string to it. If the message appears on screen, the code is firing. If not, you know the break happened earlier in the chain. Testing our trap. To verify our pit logic, we'll use the print string as a placeholder for the actual restart command. Add the node, right-click in the graph and search for print string. Connect the logic, pull a wire from the true pin of your branch node to the input of the print string. Dynamic messages. Instead of just typing hello, you can pull the red Boolean wire from your equal node and plug it directly into the pink in string pin. Unreal will automatically add a conversion node that translates the true logic into the actual word true on your screen. The importance of compiling. Whenever you modify a blueprint, the compile button in the top toolbar will show a yellow question mark. This means the code is dirty and hasn't been saved into the game's active memory yet. Compile. Unreal checks your logic for errors. A green checkmark means you're good to go. A red X means there's a logic error you need to fix. Save. Always save after a successful compile to ensure your progress is backed up. Verification. Hit play and jump into the pit. If everything is set up correctly, you should see the word true pop up in blue letters at the top left of your screen the moment you touch the kill Z volume. We've successfully identified the player and verified that the trigger works. In the next step, we'll replace that temporary text message with the actual logic to reset the player at the start of the level.